In 1868, a railroad carrying the future of America westward reached a place where the ground seemed to disappear. Ahead was a narrow creek. It was not a mighty river. It was not a raging waterfall. In places, the stream was little more than a thread of water running through the Wyoming mountains. But beneath that tiny creek was a canyon nearly 150 feet deep. For the engineers building America's first transcontinental railroad, that small stream had created a massive problem. The railroad could not simply climb down into the gorge and back up the other side. The grades were too severe for the locomotives of the time. Going around would mean miles of additional construction, more difficult terrain, more money, and more time. And time was exactly what the railroad did not have. So the engineers made a decision that, by modern standards, sounds almost impossible. They would build a wooden railroad bridge across the canyon, not a small wooden crossing. A structure roughly 650 feet long, rising about 150 feet above the bottom of the gorge. And then they would send a steam locomotive across it. The bridge would sway in the Wyoming wind. The timber would flex under the weight of passing trains. And the first crossing would happen before anyone could be completely certain how the structure would behave. This was Dale Creek, and for a brief moment in American history, the entire railroad depended on a wooden bridge hanging above an empty canyon. In the late 1860s, America was changing at a speed few people had ever experienced. The Civil War had ended. Settlers were moving west. Towns were appearing across the frontier. Industry was expanding, and the country was attempting something that had seemed almost unimaginable only a few years earlier. A railroad connecting the eastern United States with the Pacific coast. The Union Pacific was pushing west from Omaha while crews fought their way through the Great Plains and into the mountains. Every mile of track brought the railroad closer to its goal. But the farther west the crews went, the harder the landscape became. The plains had been difficult enough. Then came rivers, then rocky ridges, then mountains, and eventually, the railroad reached the high country around Sherman Summit in what is now Wyoming. At more than 8,000 feet above sea level, this was already one of the highest points on the Union Pacific Line. The terrain was severe, the weather unpredictable, and the construction crews were working under enormous pressure. But just when the railroad seemed to have conquered another major obstacle, the landscape presented a new one. Dale Creek. The creek itself was almost laughably small compared with the railroad that had arrived above it. But the water was not the problem. The canyon was. From the railroad grade, the ground suddenly fell away. Far below, the narrow stream disappeared into the depths. A locomotive could not simply descend into the gorge and climb back out. Steam locomotives depended on manageable grades, and the railroad had to maintain a practical route through the mountains. There was also the question of speed. The railroad was not building a scenic road. It was building a transportation system. Every extra mile meant more track, more labor, more materials, and more time. So the engineers were left with a brutal choice. Change the route, delay the railroad, or build over the canyon. The third option was the most dangerous. It was also the one that could keep the railroad moving. General Grenville Dodge, the Union Pacific's chief engineer, was one of the men responsible for solving the problem. He had spent years dealing with difficult terrain, surveying routes, and finding practical solutions under pressure. The railroad did not have the luxury of waiting for a perfect bridge. It needed a bridge that could be built with the technology and materials available right then. And in 1868, that meant timber. The answer was a massive wooden trestle. The idea was simple in theory. Build stone foundations, raise timber supports, connect them into a rigid framework, carry the railroad tracks across the top. The reality was anything but simple. The materials had to reach a remote construction site in the middle of the Wyoming mountains. Much of the timber was prepared in the Midwest and transported west by rail, traveling hundreds of miles before it could become part of the structure. The workers then had to transform those pieces of timber into a bridge towering above the canyon. There were no modern cranes, no helicopters, no powered construction platforms, no fall arrest systems waiting for a worker who slipped. There were men, timber, hand tools, ropes, surveying instruments, and the mountain itself. The foundations had to be secured. The supports had to rise. Every piece had to meet the next one accurately. And as the bridge grew taller, the consequences of a mistake became more severe. At ground level, a misplaced beam was a problem. 100 feet above the canyon, it could become a death sentence. Then Wyoming's weather entered the equation. Wind was not simply an inconvenience. It was a structural force. The unfinished bridge was exposed high above the gorge, where strong winds could push against the growing timber framework. A bridge that was still being assembled could move before it was even complete. And that meant the engineers were not simply building a structure. They were building something that had to remain stable while being built. The closer the bridge came to completion, the more enormous the problem became. Every additional beam added strength, but every additional section also increased the structure's exposure to wind. The workers had to climb higher. They had to move across narrow timbers. They had to work with the canyon directly beneath them, and the railroad deadline did not care about the weather. The bridge had to be finished. There was no second route waiting nearby, no modern road that could bring heavy machinery around the obstacle. The railroad had reached Dale Creek, and Dale Creek was standing between the Union Pacific and the West. Then, in April 1868, the moment arrived. The wooden trestle was complete. It stretched roughly 650 feet across the canyon and rose about 150 feet above the creek below. The structure had solved the problem on paper, but a bridge is not truly proven when the last beam is installed. It is proven when the first train crosses. And now the most dangerous part of the entire project was about to begin. On April 23, 1868, the first train approached Dale Creek. The locomotive moved toward the wooden structure slowly. There was no modern testing program, no computer simulation, no instrument panel showing engineers exactly how much the bridge was bending. The first train would reveal what the calculations could not. The locomotive entered the bridge, and the wooden structure moved. The bridge swayed in the wind, 4 miles per hour. That was the speed required for trains crossing the trestle. At that pace, every movement became noticeable. The locomotive continued. The rails remained beneath the wheels. The timber held, but the people watching knew they were not crossing an ordinary bridge. They were traveling across a wooden framework suspended high above a canyon in some of the most difficult terrain on the railroad. Then the train reached the other side. The bridge had worked. The railroad could continue west. But the story was not over, because the successful crossing revealed another truth. Dale Creek Bridge was not a permanent solution. It was a solution for a specific moment in time. The bridge had been built quickly because the railroad needed to keep moving. Timber was available. Timber could be shaped and assembled faster than the stronger iron structures that would eventually replace it. But wood had weaknesses. It could burn, it could deteriorate, it could flex, and every year of service exposed the structure to Wyoming's weather. Snow, moisture, heat, wind. Again and again, the bridge had to deal with forces that did not care how important the railroad was. Then another problem began to emerge. The trains themselves were changing. Locomotives were becoming larger, heavier, more powerful. A bridge designed around the needs of the railroad in 1868 would eventually face a railroad that no longer resembled the one its builders had designed for. The bridge had not necessarily failed. The world around it had changed. And that distinction matters, because the wooden Dale Creek Bridge had accomplished exactly what its builders needed it to accomplish. It had bought the railroad time. It had allowed trains to move through the mountains. It had prevented one canyon from stopping a much larger project. But eventually, a stronger solution became possible. In 1876, the wooden structure was replaced with an iron bridge built on the same general foundations. The new structure was stronger and better suited to the changing demands of the railroad. The wooden giant was gone, but the place remained important. The iron bridge itself would later become part of another chapter in the railroad's evolution. By 1901, the Union Pacific had constructed a new alignment over Sherman Hill, shortening the route by roughly 30 miles. The old crossing was eventually abandoned and dismantled, and slowly, the Great Bridge disappeared from the landscape. The trains moved on. The technology changed. Steel replaced iron. New routes replaced old ones. And the men who had built the original wooden structure faded from public memory. That may be the strangest part of the story. The bridge was photographed. The railroad became famous. The Transcontinental connection became one of the defining achievements of 19th century America. But the workers who climbed those timbers, carried materials, assembled the structure, and stood above the canyon were not the people whose names became famous. Some of them paid an even higher price. After the first crossing, carpenters rushed to strengthen and shore up portions of the bridge as it flexed under the movement of trains. During this dangerous work, 2 workers fell to their deaths. Their names are far less familiar than the name of the railroad they helped build. Yet without workers like them, the railroad would have remained a line on a map. Today, the original wooden bridge is gone. The later iron structure is gone as well. What remains are traces of the old crossing and the foundations that once supported one of the most remarkable railroad bridges of its era. The landscape looks different now. The trains that once approached Dale Creek at walking speed are gone. The canyon is quiet. The wooden towers that once rose above it have disappeared, and the tiny creek continues to flow below. That contrast is what makes Dale Creek so remarkable. The creek was never powerful enough to stop a railroad. The canyon was, and the engineers did not defeat the canyon by waiting for better technology. They built with what they had: timber, stone, iron rails, hand tools, human judgment, and an enormous amount of risk. The Dale Creek Bridge was not designed to survive for centuries. It did not need to. It only needed to stand long enough for the railroad to keep moving. That is something we often forget when looking backward at old engineering. Modern bridges can seem permanent. Steel structures can dominate skylines for generations. Concrete tunnels can disappear beneath mountains and remain in service for decades. But many of the structures that opened the frontier were never intended to be permanent. They were temporary answers to permanent problems, and sometimes, temporary answers change history. Dale Creek was one of those answers. A tiny stream created a canyon. The canyon threatened the railroad. The railroad demanded a solution, and a group of engineers and laborers answered with a wooden structure that looked almost too fragile to carry a locomotive. Yet it did. For a few critical years, that bridge carried trains across a gap that could have delayed one of America's most important transportation projects. Then stronger technology arrived. The wooden bridge disappeared. History moved on, but the achievement remained buried in the story of the railroad itself. Because before iron and steel made enormous bridges look ordinary, American engineers were already learning how to cross spaces that seemed impossible. They did not have the materials we take for granted today. They did not have the machines. They did not have the safety systems. What they had was a problem that could not be ignored. And sometimes, that is where engineering begins. Not with perfect technology, not with unlimited resources, but with a deadline, a dangerous landscape, and one question that refuses to go away. How do you cross when there's no way around? In 1868, the answer was wood, and for a brief moment, that wood was strong enough to carry a railroad into the future. If you enjoy uncovering the forgotten engineering projects that helped build America, subscribe. There are still bridges, railroads, tunnels, machines, and remarkable structures whose stories are almost lost beneath the history they helped create. Because some of the greatest engineering achievements were never meant to last forever. They were built for one impossible moment, and sometimes, one impossible moment is enough to change everything.